Hello, and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for some Monday musings. We're going to talk about large igneous provinces. Now, as the name suggests, large igneous provinces are very large accumulations of igneous rocks. Sometimes they are referred to as LIPs or lips to shorten it. Have I ever mentioned that geologists really like to shorten things? We've got some very long names that we just... acronyms. Everyone's best friend. They are often attributed to mantle plumes or divergent plate tectonics. The current minimum threshold to be an LIP is a coverage of about 100,000 square kilometers. So this map here, all the purple with the arrows pointing to them, those are all the large igneous provinces that we know of. Large igneous provinces are created during short-lived igneous events. They often coincide with mass extinction events, global environmental and climatic changes, and changes in the hydrosphere and atmosphere. They have played a major role in cycles of continental breakup and formations, new crustal additions from the upper mantle, and supercontinent cycles. Big deals. So how are LIPs formed? It's important to understand how the mantle works and how it interacts with the crust, along with lithospheric plate interactions. The mantle is very viscous, more solid than liquid. Its flow is driven by cold crust sinking into it through subduction of lithospheric plates, while hot mantle plumes flow upward. We call this mantle convection. Most volcanism occurs due to plate tectonics. Now, sometimes the plumes rise and spread out radially beneath the plate, causing regions of uplift. We call these hot spots. The most famous ones are Hawaii and Yellowstone, but there are numerous hot spots across the globe. The origins of these are hotly contested. Yes, pun intended. There are three origins that have been proposed. One is deep, originating near the mantle outer core boundary. Another one says some originate from hot lava domes within the mantle. And lastly, some appear to originate in the upper mantle, possibly due to the breakup of lithospheric plates that have been subducted, such as the hotspot in Yellowstone. Another competing hypothesis to mantle plumes is plate ruptures. Basically, stresses in the lithosphere cause fractures in the plates, allowing melt to reach the surface through mantle convection. And yet another one, as depicted above, is that the formation of hotspots and large igneous provinces involve meteorite impacts. 7 pairs of hotspots and LIPs located on opposite sides of the globe from each other of the same age have been located. When a meteorite impacted oceanic crust, it allowed melt to reach the surface. At the same time, the energy released from the impact converted into seismic waves and propagated across the globe, converging on the exact opposite side of the planet, fracturing the crust enough to let massive amounts of magma to erupt. So, lots of ideas on how they form, but the one thing we know for sure is that they form. Likely there is an LIP in your neck of the woods. In the U.S., we have the Columbia River flood basalts in Washington, Oregon, and Idaho. It's actually the youngest and the smallest LIP, covering about 81 square miles, or about 210,000 square kilometers. It erupted during the late Miocene epoch for about 10 to 15 million years. This is a photograph I took of those flood basalts, on my way to visit my parents. In Europe, there is the North Atlantic Igneous Province, centered on Iceland for obvious reasons. It erupted from the mid-Paleocene to the early Eocene epochs between 60.5 and 54.5 million years ago. It covers around 500,000 square miles, or 1.3 million square kilometers. It's one of the few that consists of both onshore and offshore flood basalts, silts, dikes, and plateaus, including the Giant's Causeway in Ireland. In Asia, there are the... hopefully I don't butcher this too much because, again, I don't speak Chinese. emission traps of flood basalt in southwestern China. It erupted between 262 and 259 million years ago during the Middle Permian period. It covers 155,343 square miles, or about 250,000 square kilometers. It is associated with a minor mass extinction event. The Gondwana LIP is associated with the breakup of the supercontinent of Gondwana about 183 million years ago, which now consists of South America, Africa, Antarctica, and Australia. The flood basalts are mostly in South Africa and Antarctica. It erupted during the early Jurassic period and is associated with the major Triassic-Jurassic extinction event. It spans about 3 times 10 to the 6th square kilometers before the supercontinent broke up. During the early Cretaceous period, about 136 to 132 million years ago, another flood basalt occurred in South America and a little bit in Africa called this is also, I think, Spanish and African, so I'm going to try not to butcher this. Parana? I don't know what the accent on the A is. Etendeca Plateau. It covered 390,000 square miles, or 1 million square kilometers. There was also a silicic component to this province, ignimbrites, which is hard and tough from explosive eruptions. The pyroclastic sheet has a thickness between 130 to 980 feet, or about 40 to 300 meters. This makes it the largest known explosive eruption on Earth. In India, there are the famous Deccan traps, which erupted during the late Cretaceous and early Paleogene period, meaning it spanned the very famous KPG extinction event that killed the non-avian dinosaurs. They cover an area of 200,000 square miles, or 500,000 square kilometers, and probably contributed to the extinction event. Then we have the Siberian traps, which cover a vast majority of Russia, which is impressive when you consider the size of Russia. It's one of the biggest volcanic events, spanning 500 million years and covering 3 million square miles, or 7 million square kilometers. It spanned the Permian-Triassic boundary and may have contributed to the Great Dying, which, if you're not aware, is the largest mass extinction ever. If you look at the graph here, it's way above everything else. A lot of things died. Well, thanks for joining me today to learn about large igneous provinces, and make sure that you tune in tomorrow to do some fun trivia. Fossilized later.